Dr. S. Subalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and now we are on to the topic of design thinking approach on change of order of integration. In the previous videos, we have seen what is change of order of integration and the problems regarding the change of order of integration. How we will change the order, how we will change the coordinates, how we will change the limits, everything we have seen at the previous cases. But here, we are going to implement the design thinking concept for the same problem which we have discussed earlier.
What is change of integration?
So, as already discussed, what is change of order of integration? We have just got a value of x and y here. That x and y's limits are to be changed with the help of the given limits to y and x. X and y will be interchanged to y and x. That is what our change of order of integration means. Next slide.
Why do we use change of order of integration?
Why do we use change of order of integration? It actually reduces the effort we put on the calculations which we have got as the earlier case. In the earlier case, we might have some root, square root, or trigonometric values, or some probability theories. But here, after changing order of integration, it will change merely as a value, right after a value, so that it will be easier to compute. So that is what change of order of integration is implementing to us. It will be making our work easier and simplified. Next. Empathize your soul.
The next one is empathize. Understanding the physical and mathematical in engineering applications such as heat accumulation, mass distribution, and material loading. Quantities are often accumulated layer by layer. When the mathematical formulation does not follow the natural direction of accumulation, the computation becomes inefficient and difficult to interpret. To align mathematics with physics in station, the integration strategy must be redesigned.
So this is what our empathy part of design thinking is. What do we empathize here? We are facing some difficulty to compute the integration part, right? That is our empathizing status here. So what do we have here? This computation becomes inefficient and therefore it has to be redesigned. That is what our empathizing concept here in design thinking. Next slide.
Next one is define. Stating the problem clearly. Problem. Evaluate the double integral. Integral of x is equal to 0 to 2. Integral of y equal to x square to 2x into 1 into dy into dx.
So what do we do here? We are defining the problem. What do we have in the previous case? We are just actually making the problem, redesigning the problem in a computational effective way. So that is what we are doing here. This given integral will be transformed to x and y in the later case. That is what we are defining here. Okay. This is our second part of design thinking. Next slide.
Idea. Rethinking the direction of integration. Instead of accumulating area using vertical strip, we explore accumulation using horizontal strip.
So this is a major point here. On change of order of integration, what are we going to do is, we are just going to change the vertical strip in the order of y and x to the horizontal strip in the order of x and y. This is our major point in the ideation process of design thinking.
In this approach, whereas how many physical quantities are measured, simplifies inner integration, retains the same geometric region.
So what do we have here in the ideation process? We result that the inner integration becomes a simplified one to integrate, to compute, and it retains the geometric region of the problem as well. So this is what we are in need of. We will not change anything, any concept for the problem, but we are just changing the order of integration here. Next.
Change of order of integration. In first step, we set the outer limits in y direction 0 less than or equal to y less than or equal to 4. In step 2, we set new inner limits in x direction from line x equal to y by 2 to parabola x equal to root y.
Okay. So here we have got the y direction as 0 to 4. As we can notice that it is just merely a numerical value as an inner limit. So that is what we infer in the change of order of integration. But what about the other limit? What is x? X is becoming as the variable limit. So this root y to y by 2. This is nothing but a parabola. This is nothing but a line. So this is what we are in need of. We just interpret using difficult calculations of integration. We just need this thing and this is what we are in for reducing change of order of integration.
Prototype. Step 1. Identify intersection points. X is equal to 0, 2.
So in the prototype part, we will be doing the calculations error. We will be proceeding with the calculations error. What about the calculations which we have made in the previous slide? We have just got a double integral with the variable limit and the numerical limit. Those calculations have to be done here.
Step 2. Determine new limits. For a fixed value of y, from y is equal to 2x to x is equal to y by 2. From x is equal to x square to x is equal to root 1.
So this is what we have got as the new limits for y in x. That is what we are redesigning the problem using the integrals which we have got as a new limit. So this is the next step of prototyping in the design thinking concept. Next step, testing.
Inner integration. Integral y by 2 to root y dx equal to root y minus y2. Y by 2. Outer integration. Integral 0 to 4 root y minus y by 2 dy.
So this can be computed very easily using some simpler integration concepts and numerical values applications. So this is what this computation is now direct and efficient while representing the same physical area. This is what we are in need of in change of order of integration. So once the order is changed, what we have got, more complex functions can be integrated very easily like we have discussed, and numerical methods cover a converge faster. Converge faster means it will meet at a point in an easier way, in a simpler way. The same strategy applies to probability density and also the flow problems. In previous cases we have designed this change of order of integration can be applied in the probability problems or the fluid density problems or the some sort of engineering problems. Those all things can be applicable here, and this redesigning can be repeated whenever integration becomes algebraically heavy. If it is really heavy to interpret the integration concept, means we can implement the change of order of integration. So this is our approach of design thinking concept on the topic change of order of integration. Thank you.